Okay, on this second question, we're also using the trapezium rule. This time we're told there's 4 strips, and we need to find the approximate value for the definite integral between 2 and 4 of the square root of 36 minus x squared to 1 decimal place. Right, so like on question 1, if you're looking at that one, you want to go straight to page 9 in your formula book and find the formula for trapezium rule, so you've got that in front of you. One of the useful things to find out first is actually this bit here, is the value, the height, so the width of your strips. What you've got is h is b minus a. They're your limits. If you look at this bit of the formula, you're told that a and b. So a, if you look now here, you know that a is 2 and b is 6. So you've got 6 minus 2. N is the number of strips. So you're actually told that here. So you've got 4. So you've got 4 divided by 4 is 1. So that's the height, the width of all strips. So let's have a little go here. We can put our table. So we've got x and y. This time we're starting at 2 because that's our lower limit of the integral, and you're going up in ones. So we've got 3, 4, 5 and 6. If you've got 4 strips, you should have 5 ordinates. There's always one more ordinate than strip, and if you look there, we have. So you think, right, so far so good, that's all looking okay. We then need to find the y values. Well, now to find y, this question's been set up a little bit differently, but you have been given y. If you look at this bit of your formula, that's exactly the same as what you've been given here. Okay, so y is just equal to square root of 36 minus x squared. So for each one, for here, for when we're doing this one, we're substituting x equals 2. So you've got the square root of 36 minus 2 squared, so 36 minus 4. Here you've got the square root of 36 minus 3 squared, so 9. Here you've got the square root of 36 minus 4 squared, 16. Here 36 minus 25, and here 36 minus 36. Now you give your answer to 1 decimal place, so again make sure that you don't round your answers and stuff. Let's have a look at the answers. So if you pop these onto your calculator, for x equals 2, you should get 5.66. For x equals 3, you should get 5.20. For x equals 4, you should put 4.47. For x equals 5, you should get 3.32. And obviously here you're going to get 0. So check your answers, do those carefully. I've obviously had those at the ready, but you should do those in your calculator and just check those with what is on the board now. Right, so now we're going to find our approximate area. So our area is approximately equal to, and I'm going to start using this bit. So we've got half times h. We worked out h to be 1 over the side here. Okay, times, then this formula. This bit here means the first and the last ordinate. So the first one is 5.66 and the last one is 0. So 5.66 plus 0. You might as well put the 0 there just to show you know what you're doing. And then we've got twice all the middle ones. So twice all these ones in the middle. So you've got 2 times 5.20 plus 4.47 plus 3.32. Okay, and then you can finish with your curly brackets at the end, just like is written in the formula book. Then it's a case of grabbing your calculator again, having a little workout, and seeing what you get, and you should, if you pop that all into your calculator, get that equal to 15.8, and that is in fact 1 decimal place. So hopefully that's what you've got. Now on the second part of the question it says how could you use it to get a better approximation for the value of the integral. And if you have a little think about what you're doing there, you've got your graph, and you've used how many strips? We've used 4 strips. So you've got 4 areas, and each of those are going to be approximately right. So if you think the more strips you use, each individual strip will be more and more accurate. So for part B, your answer to get a better approximation, you want to use more strips, and that's all done.